All right. Hello. I hope you guys are well, and I hope you're good. Welcome to this live lesson of grade 9 geometry. So, for the next few days, I think for the next few days, I'll be looking at the Euclidean geometry topic. Okay, the Euclidean geometry topic. So, that is to say that all topics that are geometry grade 9 related, I'll be covering for grade 9. So that's for today. I'll do a session tomorrow. Tomorrow is Friday, right? Tomorrow is Friday. Or I may probably not do a session tomorrow. Maybe we'll see. Okay, it will depend. But I'm going to do a session today, the introduction session, and then we'll take it one step at a time, up until the very last bit of the geometry. So I'm intending to cover this topic. Why am I covering it now, and why am I covering it this early? Why am I doing it during the holiday? It's because I want at least for people to get exposure to it. In term 3 is very short, guys, very, very short, but the geometry topic is to be covered in term 3. So many people find geometry challenging, they don't find it nice, but that doesn't have to be the case. It doesn't have to be the narrative. We can change that. Hopefully we will change that as we go ahead and do it. Okay, let me just get an indication from those who are joining in the session. Can you hear me? Is the network fine? Are we audible? Can we make sure that we share the live to as many friends in grade 9 that we have? Maybe there are people who are here and they have friends who are also in grade 9. Friends of yours that will benefit. Grade 9. Very, very, very important topic. So I'm going to go with this one step at a time. Hopefully I will not leave anyone behind. If you feel left behind, if you are experiencing any challenges, let me know in the comment section. If you want to ask or clarify something, don't be scared to ask and clarify whatever you may need clarity about. Okay, so let's go. So geometry, okay, in grade 9 we look at lines, we look at angles, right? And then my pen is running out, so I need to resort to a blue pen, and we look at triangles. That is our main focus of geometry in grade 9. We look at lines, angles, triangles. And at the basic foundation is understanding what an angle is. Okay, we need to understand what an angle is. Okay, so for the purpose of our understanding, I'm going to draw two distinct lines, and I'm going to label these lines A, B to represent this line, and then C. So this is line AB, this is line BC, all right, and then AB, all right, and BC meet at point B. This point B is actually referred to as the vertex. Okay, so that's very important. Okay, sure, simple, I hear you. So AB is the line, all right, and then BC is also a line. We call these line segments. When they meet at B. B is called the vertex. The point where two lines meet we refer to as a vertex. And what a vertex does is it actually forms what we refer to as an angle. Okay, so this vertex forms what we refer to as an angle, right? And our angle here is measured in an anti-clockwise direction. okay, in degrees. Okay, so our angle, if you look at the direction of this arrow from here to there, we refer to that as an angle, all right, and it's measured in an anti-clockwise direction. So once again, for those who are joining in, guys, I am just doing a lesson on geometry for the grade 9s because this is a term 3 topic that is covered in grade 9. Okay, so we want grade 9s in the house. If you are in a grade that is higher than grade 9 and you just want to be here for the sake of being here because you want to listen and get the basics in for geometry, be my guest, all right? But this is a grade 9 session, and yeah, we do not chase away anyone else who is in another grade. You are more than welcome to be here, but please understand this is primarily for grade 9s. Okay. A grade 8 learner who's here may benefit from this session because grade 8s will also be doing geometry as well in this term, and the content for grade 8 and 9 is very much the same up until a certain point. Okay, so like I was saying, this is line AB, line BC. Where they meet, the point we refer to as the vertex. That's where B is. From line BC to this line AB, we have what we refer to as an angle. It is measured in an anti-clockwise direction. By anti-clockwise, guys, if you're looking at the, must be the, I don't know what they call them. Okay, I'm sorry for not knowing the word, but you know how there's the 12, 1, 2, 3, yeah. So we are moving in this direction, not in the clockwise direction, but in the anti-clockwise direction. So hence I'm saying the angle is measured in an anti-clockwise direction. Okay, and it's measured in degrees. Okay, that's what an angle is. Okay, so that's very important. We have line AB, line BC, they meet and they join at the vertex, and the vertex forms, basically these lines basically form what we know as the angle, and the angle is measured in an anti-clockwise direction and it is in degrees. Okay, very, very important. All right, so I hope we are together so far. Now, when we name the angle or we refer to this angle, I want us to note that there are various ways in which we can, the notation that we use when we refer to this angle that's here. We can either refer to this angle, and please note the notation. This angle here that is formed by this arm and this arm joined at this vertex can be referred to as angle A with a cap on top of B, BC. The middle letter tells us about angle A, B, C. Sorry, let's just remove the cap. This symbol here, which looks like an L, means angle. So we say angle A, B, C. The middle letter refers to the angle. Or we can say angle C, B, A. The middle letter referring to the angle because that's where the vertex is. Okay. So when we are naming a specific angle, we can name it in one of 4 ways, as you can see here demonstrated. We can either say, like I said, A, B, C, put a cap on top of B, the letter we are referring to, or we can say angle C, B, A, putting a cap on the letter that we are referring to as the angle, because that's where our vertex is. So where the vertex is where the angle is formed because of these two line segments, or we refer to them as arms, right? So like I said, we can either say that's angle A, B, C, as we see here, or we can say it's angle C, B, A, as you can see there. And please take note of the notation. We just put a cap on top of either B here, B there. Or we can use alternative notation, and that is put a symbol here, which we also know as referring to angle. Angle what? A, B, C. Okay, there's no cap there because we have this symbol there. But we always know that the middle letter is referring to the angle. Or we can say angle CB, middle letter A. Okay, all right. So guys, that's how we name the angles. And we do this, guys, because we cannot really say that this is angle B alone, as in like angle B alone. And I'll tell you why. The reason why we can't say this is angle B just like that is because from here to there, this is a specific measure of the angle. All right, but also please take note, and I'm just going to use a different color so that you guys can get the point, that moving still in an anti-clockwise direction from here all the way to that point. All right, and I repeat, from here all the way in an anti-clockwise direction to that point. All right, that is still referring to a angle that has to do with the vertex B. Okay, so that's why we try and not really say angle B as in like the letter B, but we try and use the arms to be able to do what I've just mentioned here, and that is to refer to angle, this angle here, which has the vertex B, as either we can say angle AB with a cap C, or we can say angle C with a cap on top of BA, CBA. That then helps us to refer to the specific angle using our arms. I indeed, Bongi goes all the time. All right, or we can utilize this, okay, where we write down the symbol, and like I said, the middle letter to the angle that we are specifically referring to. So we try and then utilize that. Okay, and I hope you guys have a clear understanding of that. Oh my goodness, once again, oh my goodness. Oh my soul. Why can't I seem to actually really get used to Because thank you so much. I can't seem to get used to this. I can't. Oh my goodness. Thank you. Yo. Thank you so much. Really appreciate the gift. Oh my soul. Thank you so much, Wongos. I really appreciate it a lot. Yay, a mighty lot. A mighty lot. Now my network is doing funny things, eh? You guys need to pray for me and pray for the network that it does not do funny things, because it is definitely sometimes the hindrance towards this work that I'm doing. So thank you so much. Thank you so much, Mungos. Thank you. Like, God bless. As always, God bless you. All right. Thank you. I really appreciate it. Like, I mean, phenomenally so, like big time. Thank you. Okay, let's continue. So I hope we understand the naming of the angle. Grade 9s, please let me know in the comment section if you guys are not understanding what I am meaning by when we refer to the angle here. All right, we say it's angle ABC. We put a cap on top of the middle letter to refer to the angle from this direction, ABC. Or we can say it's angle CBA. It's still perfectly fine if you write it as CB with a cap A. We are still talking about the same angle. If we don't want to use this sort of notation, we can use this one. Okay, we put the symbol like this, which means angle, and then we just write the letters A, B, C. We always know that the middle letter is referring to the angle, or we can say angle C, B, A. All right, this is awesome, good notation that we can utilize. Okay, now moving very steadily to the next point that I want to emphasize as we are looking at this. All right, so I'm going to move on now to a few things. we have different types of angles. And I want us to look at these types of angles. And I want you to interact with me. There is something here that we refer to as an acute angle. Can someone in the comment section let me know what is an acute angle? Acute angle. Now I want to check grade 8 work. What is an acute angle? Grade 9s. What is an acute angle? What is an acute angle? Okay. All right. I love in the comment section what I'm saying. See where it says angles greater than 0 degrees, but less than 90 degrees. Okay. All right, I like that description. Very much straight to the point. CR for Life says acute angles are angles that start from 0, okay, to 89. Okay, now CR for Life is saying it's starting from 0 to 89. Okay, and I just want to check something very quickly here. If it starts from 0 to 89, does that then mean, because more than 89 we have 89,9, is 89,9 acute? Let me ask CR for Life. I want to ask that, since that's the answer you've given me in the comment section. As for Lesejo says it's less than 90 degrees. Okay, so CR for Life is saying 89.9 is this acute? Yes, it is. So if it is acute, is your definition correct? All right. Can we then say your definition is correct? Because you said from 0 to 89. Okay. So it's very important to please take note of what you do say. Okay. So this wouldn't be a full explanation or description of what an acute angle is. Okay. But I like this description here. So viewer says angles greater than 0, which is true. Greater means bigger, or we can say larger. I mean, that's another word we can use. As long as it is bigger than 0, but less than what? 90 degrees. That is a full-on definition of what an acute angle is. Okay? Please, guys, let's take note of that, all right? And let us be very particular about the description of these types of angles so that moving forward, because as a grade 9 learner, you need to solidify your foundation of the mathematics. If you have a solid foundation of the mathematics in grade 9, then 10, 11, and 12 tend to take care of themselves like automatically, but you need to be solid here, down here. So an acute angle, I hope we can all then agree, all right? Remember, if we say angles less than 90 degrees, remember guys that there are what we call negative angles. So we're gonna step into that realm, but not now. I mean, like later on, that there are negative angles. So what we don't want to do is we don't want to say just less than 90, because I could go down 90, 89, 88, 87, go down to negative numbers. It's too general. But you see, when I say acute angles are angles bigger than 0 or greater than 0 or greater than 0, but less than 90, that's full-on description of what an acute angle is. Okay, so I hope we can be one then in how we describe an acute angle, so that we don't run into confusion. So I'm just going to scratch out this. Okay, and I'm just going to allow us to all accept that these are angles. Acute angles are angles bigger or larger or greater than 0, but they are less than 90 degrees. Okay, I hope we are on the same page. If you have a diagrammatic drawing, a visual aid, okay, A, B, C, all right, I'm sure if you would grab your protractor, put that protractor so that your straight line is on this line, then measure your angle from here to there, and then check what that line says of the protractor, where the line AB is. Then you would be able to read from your protractor what this angle is, and you would actually find that this is an angle that is between 0 and 90. Okay, yeah, so very important. So this would be like a drawing of what an acute angle kind of would look like, if that makes any sense. Let's move on to what is a right angle. What is a right angle, guys? Right. What is a right angle? And please don't say to me it's the angle that's always right. No. What is a right angle? You're taking it one step at a time. What is a right angle? Thank you, Lesejo. In the comment section, Lesejo says angles that equal to 90. Yeah. Okay, angles equal to 90 degrees. Very true. Very, very good. Okay, angles equal to 90, an angle that is equal to 90, an angle, sorry, equal to 90 degrees. Okay, so let's just say we had PQR. Yeah, so let's note this thing here. If the angle is equal to 90 degrees, then of course, right, we would say here that angle PQR is equal to 90 degrees. Okay, yeah, right. And something else to note here is that we usually say that PQ is perpendicular to QR. There's this word that we use, perpendicular. And perpendicular simply means it's when two lines, when they meet at 90 degrees. That's what the word perpendicular means. Perpendicular has to do with an understanding that two lines meet and they make an angle of what? Of 90 degrees. So this is a word that we need to be familiar with. Perpendicular. The symbol to perpendicular is a vertical line and a horizontal line. So PQ is perpendicular to QR. That means angle PQR or angle RQP. Remember, we can refer to this angle as PQR, or we can say RPRQP, all right, with the cap at the top. Or we could say angle PQR, which basically means the same thing. Remember the orientation of the way in which we refer to angles, the way we name them. So that's basically it. So a right angle is angle that is equal to 90 degrees. Very true. Let's move on. 3. What is an obtuse angle, guys? Obtuse. Hi, now we're moving. What is an obtuse angle? Obtuse. Anyone wants to share with us what an obtuse angle is? Obtuse angle. Obtuse angle, going once, going twice. Okay, Lesejo says an angle that is more than 90 degrees but less. I think that means then, okay, which is I understand, then 180 degrees. Severe says an angle greater than 90 degrees but less than 180 degrees. I think Lesego and Severe are saying pretty much the same thing, and they are both basically making sure that we are giving full definitions of what those angles actually mean. And I'm very proud. Lesego and Severe are doing the things. So I love it when learners do that, because it makes it very easy to move forward with ease. Angles that are more than and greater than mean the same thing. Okay, they are synonyms. Than 90 degrees but less than 180 degrees. Those are obtuse angles. Okay, let's take angles that are more than 90 degrees but less than 180 degrees. That is what we refer to as an obtuse angle. And if we look at it diagrammatically, if this is a horizontal line, then you can see that that angle is slightly more than the 90 degrees. You see, because we have a horizontal line, it's more than that vertical line, which would have given you 90, because it's greater than 90, but it is less than 180 degrees. This is basically what you would see, MNP. All right, and just to give us probably just a specific example, let's say we had the angle 108 degrees. Let's say this was the angle 108 degrees. 108 is a typical example of an angle that is obtuse, greater than 90 but less than 180. Given we are busy with grade 9 mathematics here, okay? The grade 11s, I'll be seeing you guys at 10 o'clock to continue with probability. So literally 10 o'clock, okay, is the time when I'll be seeing the grade 11s. Yeah, so that's that. Okay, then let's move on to the next type of angle. Straight angle. What is a straight angle? Really, all the grade 11 work at the moment is actually like the grade 12. I'm taking into consideration grade, because remember, grade 12 need to make sure that they've revised grade 11 work. So the probability that I'm doing at the moment is obviously probability that grade 11s need to also be, grade 12s need to also be up to speed with. So that will be 10 p.m. tonight. Straight angle, grade 11s, 10 p.m. Thank you so much. Let's say good job. A straight angle is an angle that equals 180. Angle equal to 180 degrees. You could say that Lesego has like this open notebook that she is referring to at the moment. Could that be true, Lesego? Or am I picking on you? That emoji is not promising. That emoji is not promising. So let's imagine a horizontal line. Okay, sorry guys, since I'm drawing freehand, we want this as horizontal as possible. The line must be straight, because straight angle has to do with a straight line. Okay, straight line. Whether that line is straight like this, or whether that line is straight like that, or whether that line is straight like any way. All right, so from here to there, from here to there, however way we look at the line, the angle, okay, we would say here KLM is equal to 180 degrees. In other words, from here, 0, even your protractor, when you place it on the side, from 0 all the way to 180. That's why we say a straight line angle or a straight angle is an angle equal to 180 degrees. So we'd say KLM is 180 degrees, or we could say MLK is 180 degrees. Okay, that's what a straight angle is, an angle equal to 180. Okay, thank you so much, Lesego. That was spot on. Then we have another type of angle which we refer to as the reflex angle. What is a reflex angle? Going once, going twice, going once, going twice. What is a reflex angle? What is a reflex angle? Yeah. Here we are recapping grade 8 work because the grade 9s need to make sure they understand these types of angles. What is a reflex angle, guys? Reflex angle. Ndate reflex. Shai says an angle equal to 360. I'm trying. No problem, Shai. Thank you so much for trying. Really appreciate you commenting there and trying. Okay. All right. I received your comment. Any other attempts? All right. Shai, you are close to the answer. All right. Just a few things we need to clarify for you. But once you are clarified, hopefully, Shai, you'll be able to understand it now and forevermore, and you will never, ever not know what a reflex angle is. But I appreciate your attempt, and thank you so much. Any other comments as far as the reflex angle is concerned, or must the maths gamer? Okay. Lesego says, I think it's less than 360. Right. Okay. Remember, if we're saying less than 360, that means we could go all the way to all angles less than 360. And my question is, does that accommodate just a reflex angle if I go to all angles less than 360? Because 50 degrees is also less than 360, 90 is also less than 360, 12 is also less than 360. Okay, so we need to make sure that we give the specific definition. Likuti Maziko says angles that is greater than 180 but less than 360. Right. Likuti Maziko. Spot on. Maziko. Thank you so much, Likuti. Yo, that's the one. Okay, so let us write Likuti's definition. This is according to the mathematician Likuti. Okay, says an angle that is greater. I'm saying angles. An angle that is greater than who? 180 degrees, but less than 360. So this angle is more than 180 but smaller than 360. In other words, more than 180, smaller than 360, because there's a specific, in between. Right? Yeah, because when I write down a specific angle, you guys should be able to say, oh, this angle is a reflex angle. Why? Because it's between 180 and 360. It has to be between 180 and 360. You could say that. An angle between 180 and 360. That's what a reflex angle is. So if we look at a diagram, okay, to kind of show an angle that could be a reflex, look at this. Okay. From 0 to, in the same straight line, it would be 180, but we are going more than 180, you see? So hence we say this is a reflex angle. More than 180, but less than 360. So let's just say this was QPS. So we would say angle QPS is what we would refer to as a reflex angle. Let's say Can you guys give me an angle that would basically, a specific angle that would be reflex, so that I can write it down here? Give me an actual angle that is a reflex angle. Just any example in the comment section, guys. Any angle that you can think of off the top of your head that is a reflex. Give me an example. I think I'll write down the first comment. Any angle. Okay, Hlai says 270. Right? 270 would definitely be reflex. Right? Yeah, definitely be reflex. Okay, if it was 270. So thank you so much, Hlai. That's a very good attempt. I just want to just check out here again here. Look at this one. We are going all the way. That would be 180 on the same line, but then we pass 180. You know, so you can see this one. All right, it's even approaching back at this line 360. It's like coming back to the starting point. Right, so a typical example there maybe would be 297 degrees. Okay, maybe let's say 300. Okay, 300 degrees. That's also reflex. Okay, so I hope you guys see this. Okay, angle, let's say X, Y, Z. And interestingly enough, we'd say X, Y, Z. Angle X, Y, Z, we'd say is equal to 300 degrees. Okay, and the thing is, this X, Y, Z is a reflex angle. Okay, from here all the way to there. That's a reflex angle. Okay. How can you come here and say the value is God? Well, the value, but that does not mean learning it needs to stop. I think Honest Manga has his manga for coming and dropping such a comment. Revolution. Come on, let's go from reflex to revolution. What is a revolution angle? Revolution angle. Revolution angle. Revolution angle. Help me out, guys. Come on in the comment section. Yeah. The viewer angle equal to 360 degrees. Hlai, it is an angle that is 360 degrees. Hlai is redeeming herself there. Hlai, initially when she first commented, when she was speaking about a reflex, she said an angle equal to 360, and she said she was trying, which was fine, and we moved on. But now we are asking what a revolution angle. Hlai is back again with vengeance, and she's saying, let's write down Hlai's definition. It is an angle equal to 360 degrees. So Hlai, you are the madam at the moment. You are the madam. Okay, very good. This is Hlai's response. It is an angle equal to 360 degrees. 100% spot on, Hlai. Thank you so much. So, if we have a line, look at this. From here, we are starting at 0. We go all the way around. Around what? Around this particular point. This point. Around it. Back to where we started. Started, back where we started. Alright? So we end where we started. So let's just draw an arrow there to indicate that we had come from the line back to where we started. We call that a reflex, a revolution angle. So here we would say angle A is equal to 360 degrees. Here we can say angle A. The reason is around angle A is 360 degrees if we go all the way around. Okay, and there's no other thing that's there. So yeah, that is it, guys. Revolution angle. I'm so proud. Okay, so we've just taken a look at the different types of angles we can find, from acute angles bigger than 0 but less than 90 degrees. Okay, can anyone give me an angle here that I can write to indicate this acute angle? Now I want to just see if people understand what they defined. You said angle, an acute angle is an angle greater than 0 but less than 90 degrees. Give me an example in the comment section of any numerical value that can be an angle that I could write here for an acute angle. Okay, Sevio says 60 degrees. Thank you, Sevio. Then we said a right angle are angles equal to 90 degrees. Okay, Shai, if we wrote 90, no, it would be completely wrong. Okay, please understand that. Remember, acute angle, it's bigger than 0. So it's not equal to 0. It can't be equal to 0. It's bigger than 0. But what? Less than 90. It can't be 90 degrees. It has to be less than 90. Okay? So if you say 90 degrees for an acute angle, you are wrong. Because the angle must be bigger than 0, but it must be smaller than 90. Okay? Let's be very careful about saying 90 degrees is acute. 60 though is an angle that's between 0 and 90. Okay, no problem. You are here to learn. All right, and I think as long as you are eager to learn and you have the humility to learn and you can correct everything that is not correct that you've been thinking, then the change can happen mindset wise and the mathematics can start going very well, better than it used to in the past. A right angle are angles equal to 90. Okay, so this box here stands for perpendicular, and we know that perpendicular means 90 degrees. So this box here means 90 degrees, guys. That's what that box means. Whenever you see this box, you know, that means 90. Just know that. That means that it's a right angle equal to 90 degrees. Then what is an obtuse angle? We define what an obtuse angle. Angles that are what? That are more than 90 degrees, but they are less than 180 degrees. And we came up with an example, 108 degrees, okay, which is fine. Straight angle, a straight angle is an angle equal to 180 degrees, okay. Okay, and there we have any straight line, like I said, any straight line, guys. From here to there, 180 degrees. From here to there, 180 degrees. It has to be from one point of the line to the other point of the line, all the way through. Then we can say the full angle is 180. That's very important. The full angle, a straight angle is 180 degrees. Reflex. Likuti did help us out and say a reflex angle is an angle that is greater than 180 but less than 360. Then we gave some examples, all right, to indicate that. Then lastly, a revolution angle. Revolution angle, Shai helped us out there and said it is an angle equal to 360 degrees. So Shai really helped us out there, and then we were able to see what that means visually. Visually, we can see that from that starting point of the line all the way to the back to the starting point, angle around the point, 360 degrees. That is basically our revolution. Okay. That was not too bad now, was it? So are we good, guys? Do we feel like we are pumped up with some new knowledge? Or maybe old knowledge that was asleep, but we've resuscitated, we've brought back to life that geometry knowledge that we need to have as we begin geometry at this point in time. Fan, thank you so much for the community fest. I really appreciate that gift. Very welcome gift that is. Long time. We haven't seen each other in some time. You see, I think I last saw you in the probability sessions that we had with grade 10. I'm only going to be having that at 10 o'clock with the grade 11s because that's where I'm actually at now. But now I'm busy with the grade 9s with geometry. Okay. Now I want us to look at these two things, these two important concepts. The concept of complementary angles versus versus what? Versus the concept of supplementary angles. Okay, so I'm going to again ask someone to tell me, okay, in grade 9. Oh, thank you for the Rosa fan. Oh my goodness, fan, thank you so much. What is a complementary angles, my dear grade 9 friends? What is a complementary angles? What are complementary angles? What are I think that's the appropriate way to say it. What are complementary angles? Do we know what are complementary angles? Okay, because we are going to compare them to supplementary angles. So I need to first ask, what are complementary angles? Okay, Shai says it is equal to 180. That's complementary.